most dangerous and biggest heavy equipment machines, working at another level. Everyone has seen construction equipment from a distance, yet few people understand what happens when engineers remove practical limits. Machines begin to appear that feel almost unreal. Their size makes sense when you learn the problems they were built to solve. Heavy machinery exists because some tasks sit far outside human strength and patience. Digging city foundations, carving tunnels through rock, preparing farmland across thousands of acres, or dismantling tall buildings cannot rely on manual effort. Scale changes everything. A project that would take years with small tools must often be finished in months. Engineers design extreme machines when ordinary equipment reaches its limits. A larger bucket reduces cycles. A longer arm improves reach. A stronger frame allows work on unstable ground. Each adjustment looks simple on paper, yet the result becomes something very different from standard equipment. Funding and necessity often meet at the same point. Infrastructure projects demand speed and consistency. Mining operations require steady output. Agriculture depends on narrow seasonal windows. Equipment grows larger and more specialized because delays carry real cost. Some machines are built to survive conditions that would destroy normal vehicles. Industrial heat, remote terrain, and waterlogged ground challenge stability and traction. Engineers respond with machines designed around those exact conditions rather than for general use. Scale also protects people. Dangerous environments once required workers to stand close to collapsing structures or unstable soil. Heavy equipment increases the distance between the operator and risk. Remote control, reinforced cabins, and precise hydraulics turn hazardous tasks into control procedures. Productivity remains the strongest reason these machines exist. A single large excavator can replace several smaller ones. Continuous mining systems remove the need for repeated repositioning. Specialized cutters reduce manual finishing work. Each improvement shortens timelines without lowering accuracy. Precision becomes more important as projects grow. Foundation depth, trench alignment, and structural removal require exact movement even when equipment weighs hundreds of tons. Modern machinery combines force with careful control rather than relying on strength alone. A simple comparison explains the difference clearly. A hand shovel moves soil one load at a time. A standard excavator increases that output dramatically. A mining excavator shifts hundreds of tons in minutes. That gap defines modern industry. Public attention often focuses on size because it is easy to notice. Engineers focus on efficiency, fuel use per ton, cycle time, operator visibility, and maintenance intervals matter more than visual scale. Large machines succeed when they perform predictable work over long periods. Specialization continues to drive progress. Equipment designed for a single task often performs far better than general machines. Soil mixing systems prepare foundations on site. Rock cutters create consistent trenches. Waste compactors shape landfill layers for long-term stability. Agriculture, mining, construction, and demolition share the same demand. Projects must move faster without sacrificing reliability. Weather delays, labor shortages, and logistical limits push engineers toward machines that reduce uncertainty. Larger equipment often delivers that consistency. Technological progress changed expectations as well. Hydraulic systems improved control. Sensors introduced measurement and feedback. Digital planning allowed operators to follow precise layouts rather than relying on estimation. Machinery became more predictable while growing in scale. Operators describe these machines differently from spectators. Size fades into routine once work begins. Visibility, response time, and stability become the focus. A machine succeeds when it feels reliable rather than impressive. That quiet reliability explains why many of these giants operate far from public attention. Heavy machinery supports systems rather than individual tasks. Excavators feed dump trucks. Dump trucks supply crushers. Crushers prepare material for reuse. Each machine functions as part of a chain. Increasing the capacity of one stage often requires scaling the others. Environmental considerations now influence design decisions. Efficient machines reduce fuel use, precision reduces waste, and controlled demolition improves recycling. Larger equipment can complete work with fewer passes, which lowers disturbance to surrounding areas. Historical progress shows a steady pattern. Early machines replaced manual labor. Later machines increased output. Modern machines focus on consistency efficiency, safety, and integration with planning tools. Size grew alongside these changes, yet the purpose remained the same: remove limits that slow essential work. Many machines shown later may look unusual at first. Their shapes reflect the task rather than appearance. Long arms, oversized tracks, rotating cutters, and modular transport systems exist for practical reasons. Understanding why these machines exist makes their scale easier to appreciate. They are built because certain tasks leave no alternative. When the ground must move quickly, structures must be removed safely, or resources must be extracted continuously, extreme machinery becomes the logical answer. Moving something enormous creates another challenge. Size stops being the most impressive detail. Movement becomes the real test. This is where SPMT platforms enter the picture. At first glance, they look like simple rolling frames, but the wheels reveal the truth. Dozens, sometimes hundreds, move together with precise coordination. Each wheel turns independently. Structures weighing thousands of tons begin to move slowly across the ground. Refinery modules, ship sections, bridge components, and even entire buildings travel this way. Platforms rotate in place, slide sideways, and navigate tight industrial spaces where ordinary vehicles cannot operate. Progress happens gradually. Precision matters more than speed. Transport solves one challenge. Some machines focus on transforming material where it already sits. Landfill compactors pass repeatedly over waste until unstable piles become dense layers. Soil mixing machines descend into the earth and blend soil with binding material beneath the surface, turning loose ground into structural support. Rock cutting equipment slices through reinforced material with steady pressure. Screening machines separate mixed material into usable streams ready for reuse. Processing reduces the need for constant hauling. Work continues without interruption. The next machines operate where strength alone is not enough. Forestry equipment combines power with control. Tree harvesters grip trees, cut them, and guide them safely to the ground while protecting nearby growth. Mulchers and crushers clear vegetation quickly for development or agriculture. Stump grinders remove dense root systems that would otherwise slow construction. Forestry machinery supports more than logging. Land preparation improves access roads, reduces wildfire risk, and prepares sites for infrastructure. Controlled strength defines their purpose. Mining introduces a different scale entirely. Mining equipment operates where material volume defines success. Dump trucks like the Caterpillar 797F carry hundreds of tons per load. Excavators and loaders work together as part of a coordinated system that keeps material moving continuously. Mining machines often remain on site for years because transport is impractical. Assembly happens near the operation, and maintenance keeps them running through long service cycles. Reliability matters more than speed. The impact becomes visible at the landscape level. Mining equipment reshapes terrain gradually yet continuously. Material removal reveals new layers and alters elevation across the site. Technology now changes how these machines operate. Automation entered heavy equipment gradually. Sensors monitor load weight and machine position. Systems warn operators before unsafe movement occurs. Autonomous tractors follow planned routes. Remote operation allows work in hazardous environments without direct exposure. Automation also addresses labor shortages. Smart Assistance helps new operators perform tasks accurately while gaining experience. Future systems may coordinate entire fleets from remote centers. Despite technological progress, scale remains the most striking feature. Large machines sit outside the everyday experience. Standing near a mining truck wheel changes perception immediately. These machines reflect the ambitions of modern infrastructure. Cities expand, energy demand increases, and global supply chains depend on steady material flow. Heavy equipment supports those systems quietly. Engineering decisions behind these machines often remain invisible. Structural reinforcement, hydraulic design, cooling systems, and control software all contribute to performance. Visual scale represents only part of the story. Closing statement. Watching these machines work reveals a different kind of motion. Movement appears slow, yet output remains enormous. Productivity hides inside steady repetition. Heavy equipment represents solutions to limits that once slowed progress. Feeding growing populations, building infrastructure, extracting resources, and managing waste all depend on machines capable of sustained effort at scale. These machines shape daily life without direct visibility. Roads, buildings, energy systems, and food supply all trace back to equipment operating far from public attention. Heavy equipment reflects a practical truth. Progress depends on tools built for difficult tasks. Size, precision, and durability become necessary rather than optional. Which machine stayed in your mind the longest? Share your choice in the comments. Subscribe if you enjoy exploring the engineering behind machines that quietly keep the world moving.